Welcome back to the sixth section of Chapter 5. In this section, we're going to be looking at the quadratic formula. The quadratic formula gives us another option to be able to solve quadratic equations that's not factoring or completing the square. It's much more computational. You probably saw this in Algebra 1, and it's that great big formula that's hard to use. It's not that hard to use, but yes, it is long and obnoxious. However, it doesn't take the number sense that factoring does, and it can get us an answer even when factoring doesn't work. And so we're going to see where it came from and how do we use it. So looking at our learning targets, I can solve quadratic equations using the quadratic formula, and I can classify roots using the discriminant. Not the determinant, that would be a matrix thing, the discriminant, which is actually just part of the quadratic formula. And so, what is the quadratic formula? Where does it come from? Well, it actually comes from completing the square. We've been completing the square for a few days now, and you're probably seeing like, wow, we're doing the same thing over and over and over. So instead of doing it for a specific equation, why don't we do it for a general equation where we use a, b, and c for our coefficients? We can complete the square here. First step, we want to move that c over to the other side. So we subtract. And then we need to get the x squared by itself. So let's divide everything by a. So we have b over a, x, and a negative c over a. This is a negative. It kind of blends in with the fraction bar, though. And so now we can do the completing the squared step. We're going to have to divide this b over a by 2. Well, that would be b over 2a. And then square that and add it to both sides. So b squared over 4a squared. And we're adding that to both sides. Well, what is c over negative a? Oh, the negative just on the bottom. C over negative a plus b over 2a squared. How do we combine those? Well, you don't really combine those. Let's just multiply out the squared. B squared over 4a squared minus c over a. We can now combine the fractions. We just need a common denominator for a squared. So we just need to multiply these guys by 4a. So we have 4ac. So b squared minus 4ac over 4a squared. That's just common denominator, combine the fractions. Now to solve for x, we can square root both sides. So we get plus or minus the square root of this side, which can simplify. The top won't simplify, but the denominator, the square root of 4 is 2. Square root of a squared is a, so that puts it over 2a. Notice we still have the plus or minus. And then we can subtract the b over 2a over, and notice it already has a common denominator. So we can just put everything over 2a to get x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That is the quadratic formula. Now the question, are you going to have to go through the steps to derive it? No, not at all. But seeing where it came from, it's not just this magical, mystical thing that works. It's actually just completing the square, the same thing we've been doing with the generic variables. Now you can just take that a, b, and c and plug it into the quadratic formula. Honestly, I'm not going to complete the square. I'm just going to plug it into the quadratic formula and then simplify. So that's what the quadratic formula is. It looks like this. We're going to see how to use it. That's going to be way more important than where it came from. So if you were struggling in this area, that's not a problem. But here it is. And now the discriminant. The discriminant is actually the stuff inside the square root. It's that b squared minus 4ac. And this can tell us how many and of what kind of roots we will get. If this is less than 0, that makes it a negative number. What happens when we take the square root of a negative number? We get imaginary numbers. There's going to be two complex solutions and no real solutions. If we were graphing a quadratic equation, a quadratic function, with a discriminant less than 0, it will not have an x-intercept. It'll be either a positive one with the vertex being positive or a negative one with the vertex being negative, and it won't cross the x-axis. If it equals 0, there's exactly one real solution, and it is the vertex, because the square root of 0 is just 0. Negative b plus or minus 0 is just negative b over 2a. Negative b over 2a, that's the equation for the x part of the vertex. Remember we saw that the other day? This negative b over 2a was what we used. It's our axis of symmetry. It's the x part of the vertex. That's very, very useful. And so this takes into account the symmetry. We have the vertex plus or minus a certain amount. So we go each direction from the vertex to our zeros. And so if x is greater than 0, there are two real solutions because of that symmetry. And so we have some methods of solving quadratics. We have by graphing. Now by graphing gets us an estimate. It's like guess and check. It is not the best way of doing it. However, there are times where maybe graphing gets you a good idea of what you need to be looking at. We have by factoring. That's, if we can factor it, we can do that. And if you can factor it, factoring is the quickest, easiest way of solving a quadratic, if you can factor it. We have by using a square root, which works out if you don't have an x term. If you just have x squared plus a number, you can use a square root. If you do have an x term to use a square root, you complete the square, but we don't need to complete the square anymore. We can use a quadratic formula. So our two methods of solving quadratics would be by factoring and by using the quadratic formula. I know people will ask, well, how long does it take you to factor something? Well, a couple seconds, because if I can't see what the factors are in a couple seconds, I'm going to plug it into the quadratic formula. This formula, these numbers, they don't scare me. You just plug it in, then you crunch a couple numbers. It might be calculator work at that point, but it's just some multiplication and addition. You plug it in, you get the answer. Sometimes it turns out where I get, well, the answer was 17 and 3. Hey, I could have factored that, but I didn't see it. I didn't spend a ton of time looking for it. If you can't factor it right away, plug it into the quadratic formula. If you have like a 2x squared or a 4x squared or something like that, the quadratic formula might be easier because you don't have to worry about that leading coefficient in factoring. And so, how do we use the quadratic formula to solve quadratic functions? Well, we get quadratic functions. First step, we need to set it equal to 0. 0 equals this. I know some people just kind of drop off that whole equal sign. You can't drop off an equal sign. It starts as an equation. It needs to continue being an equation up until the answer, which is an equation, x equals a number. So we have our equation. We have a is negative 3, b is 4, and c is negative 4. Sometimes, especially when you're starting out or if you're struggling doing this, actually write that out as the next line. A equals negative 3, b equals 4, c equals negative 4. It'll help keep those negatives where they go, and it's easier to plug stuff in if you have it written right there. After a few times, you should probably be able to stop doing that and just look at it from the equation. However, if you're doing things like missing this negative, it's not a bad idea to say c equals negative 4. Now we can plug this into the quadratic formula. It's negative b, so that's going to be a 4. B is a 4. A is a negative 3. C is a negative 4. And A is negative 3. So we just need to plug those numbers in. And then crunch the numbers. Start inside the square root. We have 4 squared is 16. And we have negative 4 times negative 3 times negative 4, which is negative 48, and then over negative 6. 16 minus 48 is negative 32. So you have negative 4 plus or minus the square root of negative 32 over negative 6. Simplify inside the root. Well, negative, it's going to have an I on it. 32 is a whole bunch of 2's. It's actually 16 times 2. Square root of 16 is 4. So we can get negative 4 plus or minus 4 root 2 times I, or 4I root 2, over negative 6. And now, especially if you have a complex number, an imaginary number, I would split the fraction up. Specifically for complex numbers, because complex numbers, remember, have two parts, a real part and an imaginary part. When it's all over the same fraction bar, those get mixed. So I'd split it up. I would do it anyway, because one of the mistakes people make is they try to simplify wrongly here. They'll simplify one piece of the numerator with the denominator, and not both pieces. If you split them up into two fractions, you can simplify each of them separately, and it actually becomes easier. And so we have negative 4 over negative 6 plus or minus 4 root 2I over negative 6. Negative 4 over negative 6 is just 2/3. Plus or minus 4 over negative 6 is negative 2/3. But that negative doesn't really matter because we already have both plus and minus. It makes it minus and plus, but who cares? It's plus or minus. So we don't really need to worry about that negative because it's covered. So we have 2/3 plus or minus 2 root 2I over 3. And there's the answer. Here, this one would not be a factoring one. That would not work out well. And because of this 3, if we were trying to complete the square, we'd have to divide everything by negative 3. It would actually be a fairly difficult problem to complete the square with this as well. But quadratic formula, we plug it in, our answer ends up as a fraction, but we didn't have to work with them throughout. So that's one that's a pretty big problem. Here's another one. F of x equals 7x squared minus 3. So make it equal 0. In this case, we don't have an x term, so we don't need to use the quadratic formula. We can just add the 3 over, then divide by 7. So we get x squared equals 3/7. Square root both sides. X equals plus or minus the square root of 3/7, which can split up numerator and denominator, and then multiply by root 7 over root 7, because we want to rationalize the denominator. We want to get that square root out of the denominator. So in the top we have root 3 times root 7. 3 times 7 is 21, so that's root 21 over 7. So x equals plus or minus root 21 over 7. Didn't even use quadratic formula? You don't have to. Could you have? Yes. A equals 7, C equals negative 3, and B equals 0 because we have plus 0x. And so that would be 0, that would be 0, and we could have just plugged in the A and C. It would have come out perfectly fine. So try this. I actually have 2 of them for you to try. This is the first one. Try this one. F of x equals 3x squared minus 10x plus 3. I recommend using quadratic formula here, although not necessary. But I would try it practicing with the quadratic formula. Go ahead and push pause, crunch the numbers, and when you're ready, come on back. How did you do? Did you actually come out with nice numbers? Yeah, this one actually comes out with nice numbers. You can factor this, but by looking at it, my first instinct would be, no, we're going to go with quadratic formula on this one. So let's plug it in. The b is negative 10, so we have negative 10 plus or minus the square root of negative 10 squared minus 4a is 3 and c is 3 all over 2 times a. Negative 10 is just positive 10 plus or minus the square root of 100, because that negative gets squared. If you just plugged into your calculator negative 10 squared, it'll give you negative it's a positive 100 minus 4 times 3 times 3. That'll be 36 over 2 times 3 is 6. 100 minus 36 is 64. And the square root of 64 is 8. So we have 10 plus 8 divided by 6 and 10 minus 8 divided by 6. 10 plus 8 is 18 divided by 6 is 3. And 10 minus 8 is 2 divided by 6 is 2 6 or 1/3. Look, 10 plus 8 divided by 6, 10 minus 8 divided by 6. So this one's 3, and this one is 2 over 6, which is 1/3. So x equals 3 or 1/3. And notice, hey, it came out nice. That means we should have been able to factor this. Yeah. This factors into 3x minus 1 and x minus 3. Because 3x times x is 3x squared. Then 3x times negative 3, that's minus 9x. Minus another x is minus 10x. And then negative 1 times negative 3 is 3. We have this. That means 3x minus 1 equals 0. And x minus 3 equals 0. And so if 3x minus 1 equals 0, we can add 1, divide by 3, so x equals 1/3, or x equals 3, which is exactly the same thing that we got over here. So, hey, if you saw that I can factor this, notice this is a lot easier. But it requires a bit more thinking, because you have to think in this factoring step. This one, yeah, quadratic formula is long and obnoxious, but it doesn't require thinking. It requires computation. And computation is a lot easier than thinking. It's just long and obnoxious. So in this case, you could have done either way. In the next one, quadratic formula all the way. So try this one. F of x equals x squared plus x plus 1. Everyone always thinks, oh, this one's going to be easy. A, B, and C are just 1. Well, you can't factor it, so plug it into the quadratic formula. Go ahead, pause, and come back when you're ready. All right, did you actually do it? If not, go back, pause it, and do it. Participate in your own education. That's what this is about. So, you need to plug it in. A, B, and C are all 1. So plug it in. We have negative 1 plus or minus 1 squared, minus 4 times 1 times 1, all over 2 times 1. Well, let's see. 1 squared is 1. This will just be minus 4. So that'll be a square root of negative 3, which is going to give us an imaginary number. Hey, that's why you can't factor this. And so square root of 3 is just going to be root 3. So this will just be negative 1 plus or minus root 3i over 2, or I root 3 over 2. And then, just like over here, it's imaginary, it's complex. Let's split this up. Let's go negative 1/2 plus or minus I root 3 over 2. Right? And so, that's using the quadratic formula. Again, it doesn't take thinking, it takes computation. It's a completely different skill. And that would be the topic. We're using the quadratic formula to solve quadratic equations, but remember, that's not the only option we have. If you can factor it, I would recommend factoring it. Solving by graphing, I would not recommend. This one, it wouldn't help you out at all. This one, you'd get some decimal approximation, which would be wrong because it's not a decimal approximation we're looking for. This one, you could have probably solved by graphing and it would have been okay, but not a habit to get into. You want to be factoring or using quadratic formula. Anyway, I will see you next time. Until then, happy mathing.